here we got two test function, right? One phi of x and another one is a phi star of x. So after using this, we have to find out size of the test and power of the test, right? And also here how to determine k value and k star, right? So here for the first one we have to find size of the test and also power of the test, and also for the second one we have to find size of the test and power of the test, that is two size of the test and two power of the test, right? So you'll obtain the size of the test using first test function. Okay, that is using the first one. Size of the test is expectation of phi of xn equal to alpha, right? Which implies a probability of k less than xn less than theta, or theta naught less than xn less than theta 1 equal to alpha, right? Then we can write these term as p naught k xn less than theta naught plus p naught theta naught less than xn less than theta naught equal to alpha, right? Here probability of theta naught less than xn less than theta 1, right? Under h naught, we know that under h naught theta naught less than xn less than theta 1 is 0, then this term is 0, right? Then here this one, that is p naught k less than xn less than theta naught equal to alpha, right? So we can write this as integral over k to theta naught f of xn dxn equal to alpha. So here f of density of x nth order statistic, right? What is the density of nth order statistic in the case of if x follows uniform 0 comma theta distribution? You know that the density of nth order statistic is n into f of x, where x equal to xn power n minus 1, and f of x, where x equal to xn, right? Here x follows uniform 0 comma theta, that is small f of x equal to 1 by theta, where 0 less than x less than theta, right? Then what is a capital F of x equal to, we solved, right, in the last size of the test problem, right? That is integral over 0 to x f of x dx, which is equal to 0 to x integral over 0 to x 1 by theta dx, it's equal to x by theta, right? Then f of xn, the nth order statistic is n into capital F of xn, that is this value, right? That is xn by theta power n minus 1 into 1 by theta, right? We can write this as n xn power n minus 1 divided by here n minus 1, right? Theta power n minus 1, and here theta, then is theta power n, right? Here we want to integrate k to theta naught f of xn dxn equal to alpha, right? Which implies the integral over k to theta naught n into xn power n minus 1 divided by theta power n dxn equal to alpha, right? Then we have to integrate that term, right? Which implies we can take n divided by theta power n is outside, then integrate k to theta naught xn power n minus 1 divided by n minus 1, right, into dx equal to alpha, which implies n by theta power n integral over integrate of xn power n minus 1 is xn power n divided by n theta naught k, right, equal to alpha, which implies n by theta power n. Here we will substitute the value of that, right? It is theta naught power n minus k power n divided by n, right, is equal to alpha, which implies here n and got cancelled. Then you can get theta naught power n minus k power n divided by theta naught power n. Here theta naught, okay, gives is under size of the rest is under h naught, right, here equal to alpha, right. Then we can write this as 1 minus k by theta naught power n, right, which is equal to alpha here. But here we need to obtain the value of k, right? That means which implies k equal to, what is k then? 1 minus alpha in theta power n, and here n, right, n, which implies k equal to 1 by alpha theta naught power n whole power 1 by n, right, which implies k equal to 1 by alpha power 1 by n into theta naught, right. This is k value. Then we have to find the power of the test based on the first test function, right. Then power of the test power of the test, right, that is a expectation of phi of xn under h1, which implies a probability of k less than xn less than theta naught, or here we are using the first test, right, that is k less than xn less than theta naught, or theta naught less than xn less than theta 1, right. That is here for probability of k less than xn less than theta naught, or theta naught less than xn less than theta 1, right, which implies the probability of k less than xn less than theta naught plus probability of under h1 theta naught less than xn less than theta 1, right, which implies here what is value, that is integral over k to theta naught f xn dxn, right, plus integral over theta naught to theta 1 f xn dxn, right. Which implies we can here k to theta naught and theta naught to k. What is the value there in under h1? K to theta naught and theta naught to k, theta 1 is same value, right. Then we can write it's together, the range together, okay. We can write integral over k to here k to theta naught plus theta naught to theta 1, right, and we know that their values are same, so we can write k to theta 1, okay. It is k to theta 1 f of xn dxn, okay, which implies k to theta 1 f of xn dxn, which implies k to theta 1, what is the value of f of xn, the density of nth order statistic, that is n into xn power n minus 1 divided by theta 1 power n, right. Then dxn, then integrate that term, that is integrate this term, then we can get what is the value, it is 1 minus k divided by theta 1 power n, right, which implies here what is the value of k then, from the size of the test we obtain the k value, that is 1 minus alpha power 1 minus 1 by n theta naught, right? So here we will substitute the value of k, that is 1 minus alpha power 1 by n theta naught divided by theta 1 whole power n, right? You can write these power of the test as 1 minus alpha, here 1 by n, and here n, right? That is 1 minus alpha power 1, right? Then here theta naught power n, that is we can write theta naught, here also theta 1 power n, that is we can write theta naught divided by theta 1 power n. Okay, this is the power of the test, that is beta, right? Then consider the second test function, that is 5 star of x, 5 star of xn, right? 5 star of xn. Here the size of the test is 1 into probability of 0 less than xn less than k star, or theta naught less than xn less than theta 1 equal to alpha, right? The size of the test. Using that we have to obtain what is a k star and also what is the power of these tests. Okay, using the second test what is that, 5 star of xn, right? Then size of the test, that is expectation of 5 star of xn under h naught, right, which is equal to alpha, which implies probability of 0 less than xn less than k star, or theta naught less than xn less than theta 1 equal to alpha, right? Which implies you can write a probability of 0 less than xn less than k star plus probability of theta naught less than xn less than theta 1 equal to alpha under h naught, right? We know that this value is 0 because under h naught theta naught less than xn less than theta 1 takes the values 0, right? And here this term is integral over 0 to k star f naught of xn dxn equal to alpha, right? Then here we have to substitute the value of density of we have to substitute the density of nth order statistic, that is n into xn power n minus 1 theta naught power n, right? dxn equal to alpha, right? Then after integrating these terms, then you can get n by theta naught power n xn power n divided by n 0 to k star, right, equal to alpha, which implies n got cancelled, then 1 by theta naught power n, here k star power n, right, minus 0, right, it's equal to alpha. So which implies k star divided by theta naught whole power n equal to alpha, right? Here 0, right? Then k star divided by theta naught whole power n equal to alpha, right? So here we need to find out what is a k star value, right? That is k star equal to, what is k star then? Alpha into theta naught here 1 by n, right? Here k star equal to theta alpha power 1 by n into theta naught, right? And also we have to find what is the power of the test for the second test function, right? That is power of the test, that is expectation of 5 star xn under h1, right, which implies p1 0 less than xn less than k star plus p1 theta naught less than xn less than theta 1 equal to, what is that power? We can take as a beta star, okay, for the second one. Equal, that is a beta star. Then which implies integral over 0 to k star f1 of xn dxn plus integral over theta naught to theta 1 f1 of xn dxn equal to beta star. Okay, then we will substitute the value of density of nth order statistic, that is integral over 0 to k star n into xn power n minus 1 divided by theta 1 power n dxn plus 0 theta naught to theta 1 n into xn power n minus 1 divided by theta 1 power n dxn equal to beta star, right? So integrate these terms, we can get the value k star divided by theta 1 power n, right, plus what is then this term, integrate this term, then we can get theta 1 power n minus theta 1 power n divided by theta 1 power n, right? So in your notebook you have to integrate this term, then you can write this step, okay, then h is equal to beta star, which implies k star divided by theta 1 power n plus, you can write this term as 1 minus theta 1 power theta 1 power n, okay, which is equal to beta star. Here we know that what is the value of k star, right? What is the value of k star? K star is alpha power 1 by n into theta naught, right? So here we will substitute the value of k, that is 1 minus alpha power 1 by n theta naught, right, divided by theta 1 and whole power n, plus here 1 minus theta naught divided by theta 1 power n equal to beta star, right? Which implies here alpha power 1 by n, right, and here n, then it becomes alpha power 1, right? It is alpha into theta naught divided by theta 1 power n plus 1 minus theta naught divided by theta 1 power n equal to beta star. So we can write these term as 1 minus alpha, we can take theta naught divided by theta 1 power n common, right? Then you can write as 1 minus alpha into 1 minus alpha into theta divided by theta 1 power n, right, which is equal to b star. And this is the power of the test 4 second test function, that is a 4 power of the test for the test function 5 star of xn, okay. So next we will go for another problem similar like uniform 0 comma theta problem, okay. It is the question is given a random sample of size n from a distribution size n from distribution with the density f of x theta equal to 2x divided by theta square, where 0 less than x less than theta. Construct most powerful test for testing H naught versus, what is H naught? Testing H naught, theta equal to theta naught versus H1, theta equal to theta 1, where theta 1 is greater than theta naught. Okay, this is the question, that is given a random sample of size n from distribution with the density f of x theta equal to 2 theta divided by theta square, where 0 less than x less than theta, and construct a MP test for testing h naught theta equal to theta naught versus h1 theta equal to theta 1, where theta 1 is greater than theta naught. Okay, so here similar like a uniform distribution problem, we have to find out the ratio, and it will give a two critical region. Okay, two test function also. Then we have to find out two size of the test and two power of the test, and also k value and k star value. Okay, we'll solve that problem. Under h naught, likelihood is theta naught x1 x2 so on xn equal to, what is the likelihood then? If f of x theta equal 2x divided by theta power 2 theta square, then the likelihood is 2 power n summation I 1 to n xi, sorry, 2 power n product I from 1 to n xi theta naught power 2n. Okay, if 0 less than xn less than theta naught, here is given that theta 1 is greater than theta naught, so we have to write here theta naught less than xn less than theta 1, similar like the uniform problem. Okay, where 0 is less than 0 if theta naught less than xn less than theta naught 0 otherwise. And what is the likelihood under h1? Is equal to 2 power n product I 1 to n xi divided by theta 1 power 2n if 0 less than xn less than theta naught, right? And then what is if theta naught less than xn less than theta 1? Same, right? Because it takes the values under h1 is take the value 0 to, then the density is same, because if here is given that f of x theta is equal to 2x divided by theta square, where the range is 0 less than x less than theta, right? Under h1 the range becomes 0 less than x less than theta 1, right? Then here also 2 power n product I 1 to n xi divided by theta 1 power 2n 0 otherwise. Okay, then we know that we rejected one of the first large ratio, so that we have to take the ratio, right? This likelihood of theta 1 x1 so on xn divided by likelihood of theta naught x1 x2 so on xn equal to theta naught divided by theta 1 power 2n if 0 less than xn less than theta naught, right? Here we divide this term to these, then we can get here these and these term got cancelled, right? Then can here only remaining this term, that is 1 by theta naught power 2n 1 by theta naught power theta 1 power 2n, right? Then we can write that as theta naught divided by theta 1 power 2n, right? And if theta naught less than xn less than theta naught theta 1, then what is the ratio? That is this term divided by 0, right? That is infinite, then 0 otherwise. We know that we reject h naught for the large ratio, so here is infinite is a large value, right? So this is one of the rejection region. Then we have to find out for the which value we will reject h naught, right? In this range. For that we have to draw a graph, right? Similar like that uniform 0 comma theta distribution problem. 0 to here, this is the xn, okay. 0 to theta naught, 0 to theta naught, and theta naught to theta 1. Here we'll take the ratio, that is L theta 1 x divided by L theta naught x. This is the constant value, right? And here infinite. There is a theta naught divided by theta 1 power 2n, here infinite. And here from these 0 to theta naught is theta naught divided by theta 1 power 2n, right? 0 to theta naught is takes the values of theta naught divided by theta 1 power 2n. Then after theta naught to theta 1 is the ratio takes the value infinite, that is here, right? Then here this is constant, right? Then we have to take here is a k star and k, right? Similar like the last problem. Then they will get two test functions, right? One these and it is. And what is the test function then? Then test function for testing h0 versus h1 is phi of xn equal to 1 if k less than xn less than theta naught, or theta naught less than xn less than theta 1 in the first test function. Okay, the second test function is take the value rejection region is 0 less than xn less than k star, or theta naught less than xn less than theta 1. Okay, so we will write first of phi of xn equal to 1 if what is the critical region? It is k. Rejection region is k less than xn less than theta naught, or theta naught less than xn less than theta 1, 0 otherwise. And the second test function is phi star of xn 1 if 0 less than xn less than k star, or theta naught less than xn less than theta 1, okay, 0 otherwise. And here also we have to obtain the size of the test for phi of xn, and also we have to obtain size of the test for phi star of xn, and also we have to find the power of the test in both case, okay, both test functions, and also we have to obtain k and k star value. Okay, here also we are using f of xn, right? Here x follows a distribution with the density is 2x divided by what is that, 2x divided by theta square, right? 0 less than x less than theta. So we want to obtain the nth order statistic, right? That is n into f of x, n equal to xn power n minus 1, f of x equal to nx, right? That is f of xn, right? Then we can get f of xn equal to 2n xn power 2n minus 1 divided by theta power 2n. Okay, this is the nth order density of nth order statistic in this problem. That is a density with the distribution with the density 2x divided by theta square. Okay, so here using this you have to find out size of the test and power function of the test. Okay, there is one more problem. So here you have to find size of the test and power of the test in both cases, in first test function and first and second test function also. Yeah, and also find out k and k star is your homework. And one more question for the homework question, that is same question. Density is 3x square divided by theta cube. Okay, this is your homework question.